Hello and welcome to this presentation on the gateway design pattern. In this discussion, and this is a discussion just so you know, this is a new style for me on my YouTube channel to do with programming and IoT, where you actually see me on video. So I'm planning to do this in probably or potentially two parts. The one part where we have this discussion, and then the next part where I show you the code. Now, depending on how long each of these gets, I might label this video as part 1 and then the other one part 2. But if you don't see a part 1 and part 2, then I'll probably combine them into one video. So I'm not sure how this is going to turn out. And please let me know if you like this format where you want to see me talk and explain things. And maybe in time I can kind of edit it in such a way that it's happening simultaneously. But for now, I don't have that set up, but I could be sitting in front of a computer and talking to you and recording the screen. So here it goes. The gateway design pattern is becoming more and more prominent, or should be becoming more and more prominent, because we are constantly talking to other services. So essentially, the gateway design pattern is about, or you would use it when you are talking to other services. By services, I don't mean a database, but I mean other service applications, other APIs, where your system is using external services, or by external, I mean external to the system you're building. And the primary purpose of any pattern, any object, any class, is to give you this abstraction. So obviously the gateway design pattern is about that abstraction, giving you an abstraction from that service that you're talking to. Now, there are a few other patterns that are synonymously used with the gateway pattern, such as the proxy and the service agent. Now, in my mind, these patterns are different. I'll try and explain how that is. So imagine a set. The gateway is sort of the outermost set. The proxy is a subset of the gateway, and the service agent is a subset of the proxy. It's just like three concentric sets, if you will, where the gateway is the outermost set. And the reason, and this is not so clear in many books and other areas that I've read, so I've over the years come to my own sort of way to distinguish between these patterns, and it fits really well for the most part. So if you, especially in a team, in a team, it's important to have nomenclature that is not ambiguous. So if I just say, yeah, gateway one day, and then I said, use a proxy the next day, it shouldn't mean the same thing. And certainly on my team, I make it very clear what these things mean so that there's no confusion, because sometimes you want a proxy, sometimes you want a gateway, and sometimes you want a service agent. So, and then there's another pattern, fairly recent, called the API gateway, and we'll talk about that a bit as well. But for now, for the moment, I just want to talk about these three patterns: the gateway pattern, the proxy, and the service agent, and how they're all put together. And certainly in my mind, what is a service agent and what is a proxy, since they're all subsets. So the proxy is a subset of the gateway, and the service agent is a subset of the proxy. So indirectly, the gateway has a proxy and it has a service agent. So I'll start with the innermost one, the service agent. The service agent is a class that abstracts for you the protocol, HTTP, TCP, SOAP, REST, whatever. It doesn't necessarily understand the service itself that it's talking to, but it understands the protocol, the transport and the communications protocol. So TCP and REST, for example. Its API, if you will, the service agent's API will be simple, put, post, get, delete kinds of APIs. Because it's talking HTTP, let's say as an example, it doesn't quite understand the service's intricacies, but it knows that the service is talking in the form of HTTP and REST or SOAP or whatever the case may be. So the service agent is giving you that abstraction at the communications and transport layer, but doesn't quite give you the abstraction at the business layer, if you will. The proxy is typically a generated class. And we have many tools. If you're working with a SOAP service, you use the WSDL and you point this tool to that WSDL, and the tool will just produce a class for you, and they call it a proxy, which is why I decided to distinguish the proxy from both the service agent and the gateway. Because the proxy is essentially a proxy. It is bringing a distant service, if you will, closer to you. So this proxy is acting as a proxy to that service. But it's also a proxy in the sense that it is mimicking that service's API exactly. So the proxy, even though that it can communicate, or you could use the proxy to communicate with the service, the proxy's API is a replica, is a one-to-one replica of the API of that service. Now that may work in some cases and that it works as it is. But let me explain to you now the gateway and how it all fits in. It's, I think, very rare that the proxy, because it's mimicking the service's API exactly, works for your business side. And I'll give you an example. There's a couple of examples, and we'll sort of focus more on the one example. Let's say I'm working with a credit card payment service. Now there's dime a dozen credit card payment services. Each one of them gives you different percentages or charge you a certain percentage, and based on how many transactions or the amounts of transactions you transact with them over a month, they give you a better deal and so on and so forth. So it's very likely that in a business system, when you're working with a payment gateway, they might switch over to another service provider because that provider is giving them a better rate or a better deal. From a business standpoint, the business says, okay, I need to transact a credit card payment. So I'm going to give you the credit card information, the address, the name, etc., whatever is typically required for credit card transactions. And the business doesn't necessarily want to know the system. The business system that is using the gateway or the proxy, as the case may be, doesn't want to get intimately coupled to that service, having to know the nuances of that service. From the business standpoint, the business system says, okay, here's all this information. Please process the credit card transaction. The payment API might involve 2, 3, 4, 5 calls to make that one transaction occur. The business system is not wanting to be clued into that detail. So you need to keep that decoupled or abstracted from the business system. Because the proxy is mimicking that API exactly, it also surfaces those, let's say 3 methods just to do the one transaction. So the gateway is doing that part. The gateway is doing the orchestration, if you will, or some people call it the composition. Is composing the calls. One call from the business system to your gateway could potentially translate into multiple calls in a specific sequence, and the inputs and outputs go from, the response from the one call goes into the input the next call, or part of the input to the next call, and so on. So that detail of the orchestration is handled by the gateway. Now the gateway might use the proxy to do it, and the proxy might use the service agent to do it, but as far as the gateway is concerned, it is talking to that service. One method call from the business side translates to potentially multiple calls, or an orchestration, if you will, of calls within the gateway itself. The other aspect is that on the business system side, it's got certain domain models. The data structures of a certain shape. The service has got its own models. We typically call them resource models. So the distinguishing names are domain model from the business side and resource model from, like, say, a service side. Let's call it a service model, just to be clear. The business side is not wanting to talk in the language of the service. In other words, it's not going to be, and it should not be, using the models from that service. It's very easy when you're building something that decouples you from that service, because you're so focused on the documentation and various other things about that service that you leak that abstraction into your business system. In other words, the business system is using the same models that you are forced to communicate with that external service. So that should not occur. So you have to be very mindful when you're designing or implementing your gateway that the API of your gateway is working with the domain models. So the domain might give you a model that has the credit card information and a bunch of other things. And the domain model, the method might say, okay, process credit card and then return to me another model, which is my business model or the domain model. It's not the model from the server side. The service has got its own model for the requests and the responses, and the gateway has to then map between the domain model and the resource model on the way out to the service, and then on the way back from the resource model back to the domain model. Now, this mapping is not necessarily simple, but whether it's simple or complicated doesn't really matter. It is the gateway's responsibility to do the mapping. Now, the gateway might use another class internally to do the mapping, but we're not going to the detail of the design. I'm just trying to distinguish between the proxy, which is mimicking the API of the external service exactly, while the gateway, which is working for the business system, is not interested in knowing the details of that orchestration. Because from the business standpoint, it says, I've got this information for processing a transaction, credit card transaction, please do it for me. And that's it. It is not wanting to get into the nuances of that service. Because what if we change the service to another provider tomorrow? The business has not changed. So the business's API should not have to be impacted one bit. The business is still doing the same transaction or still intending to process a credit card transaction. But the other service might have a different orchestration. Maybe instead of 3 methods to make that transaction occur, it has 2 methods or 1 method, whatever the case may be. The gateway is going to handle the orchestration or the composition, some people call it, between that service and the gateway, and is simplifying that interface to that service via the gateway's API. The proxy won't do that. The proxy is actually, as I said, is mimicking one-to-one. Let's say you're working with an Azure service. They provide an SDK. And it seems like, you can simply just use that SDK in your sort of the main business system and start working with that service. Let's say it's Cosmos DB or something. You shouldn't. You should always have a gateway that abstracts you from the nuances of that SDK. And that, not to say that maybe you go to Amazon tomorrow instead of Azure. Whatever the case may be, your business system talks to a gateway. The gateway talks to some external service. The gateway may use a proxy. The proxy may use a service agent. Or you might build all of that functionality into the gateway as if it's one class because it's fairly simple, for example. The other reason is the SDK typically has every possible functionality that service might provide. Let's say in the case of Azure, these services have a whole ton of methods. But in your system, you're only using, let's say, 3 of those methods, or let's say 30% of those methods. Your gateway is surfacing only the functionality in the style of the API that the business system would like. So your gateway's API is designed as per the business system's requirement, the inputs, outputs, and the method calls, and how many method calls there are, and what those method calls mean to the business system, the names of these methods. The gateway then might use the SDK. So the SDK becomes like that proxy, if you will, to go and talk to the Azure Cosmos DB or whatever the case may be. And then tomorrow you might decide that you want to go to Amazon AWS, and the gateway changes. So you have a different implementation of a gateway that works with Azure, or it works with AWS, Amazon AWS, and maybe you interchange between them, whatever the case may be. The key aspect to remember is that the API of your gateway, the public methods or public surface of your gateway class, is designed as per the business system's requirement and is not designed as per the service you might be talking to. The shape of the models, the domain models, or the gateway's API, public methods, will expect domain models coming in and domain models coming out as a response to these methods, if there's such a response. And the gateway might have to do the mapping between your domain models and the resource models for that service. So there's 2 roles so far I've talked about. One, and I use the term, I say the gateway works for you. It works for the business. It does not work for the service. Even though it's working with the service, it doesn't work for the service. It works for you, your business system. So its API should be shaped and designed according to what the business requires. And the names of the methods should be what the business calls these names. It does the mapping between the resource model and the domain models. So on the way into the gateway, it does the mapping between the domain model and the resource models, and on the way back from the service, it maps between the resource models and the domain models. This mapping can be complicated, maybe it's simple. Whatever it is, the gateway does it. Now, whether the gateway does it by itself or it makes use of another class to do it is not the point of this conversation. But it is the gateway. The business system doesn't know the resource models. All right. Now, the third role or responsibility of the gateway and how it distinguishes itself from the proxy. Services typically talk in the form of HTTP. Let's say, if you're working with a proxy, not like an SDK, you're working with a proxy, it's basically just doing the calls, and if there's an error on the HTTP side, it'll probably give you back a HTTP status code, either of the 200, 300, 400, 500, whatever the case may be. And then somehow that, you by looking at the response content, you might get information as to what the problem was. Maybe it's in the header, whatever the case may be. Every service is different, unfortunately, but that's our life. So we deal with these different nuances. I program to exceptions, and I haven't actually made a video on that idea or that concept yet. But basically, in my C# applications, expect exceptions to be thrown when something goes wrong. I don't want to have to deal with HTTP or SOAP or whatever the case may be. So the gateway's responsibility becomes transforming HTTP nuances into exceptions. That gateway is going to do whatever it needs to do to extract any information that was responded, return to it in the form of some HTTP content in the body, but throw an exception. There are many services that respond with a 200, including like these payment gateways that I'm talking about. The response will always be a 200. But somewhere embedded in there's a flag or something that says there was an error or there was no error. And if there was no error, then this part of the JSON or XML has your data, or the other part of your XML or JSON has the error information. The gateway is going to transform all that into an exception if there's a problem. The business system doesn't want to get tied up or caught up in the nuances of that service versus another service. So that's the third role or responsibility of the gateway. So we have the gateway works for you, meaning it works for the business system. The gateway does the mapping from the domain models to the resource model, and the resource model back to the domain models. And the gateway does the exception transformation. So it transforms whatever that protocol may be, whatever the language may be that service is talking to you in, to the gateway in, transforms that, extracts whatever information required for the happy path, meaning no errors, or the unhappy paths with their exceptions. Now you typically have custom exceptions, specific exceptions for the different kinds of problems that you might get from the service. And then in the exception, the message is extracted from your response from the service and put into the exception. So as far as the business system is concerned, it makes a call. If there's no exception, it is okay. If there was an exception, it's going to handle the exception, whatever mechanism that system has built in for exceptions, without having to get caught up in the transport or communications protocol of that service. So hopefully this has been clear. I'm not showing you any code yet. As I said, the code might be in a different video, or I might just put it in towards the end of this video if the length of these videos are not long enough. Or not too long, I mean. Okay, the API gateway now. The API gateway is essentially not on your, so let's say you have a business system that needs to talk to a service. So far, we had the gateway in our application, and the gateway was talking to that service from within our application. Imagine if that service provider decided to give you the exact API that you require. So whatever your API of the gateway is, they want to make that available from their endpoints. If you can imagine that, that's an API gateway. It's unfortunate we have these names that are all similar in our industry, but that's an API gateway. It's as if the service people read your mind. They say, oh, these people are making these gateways that do this. It simplifies the orchestration and et cetera, et cetera. How about we surface for them an API on top of our API? So this is their API of the service on top of that API. So this API that's deployed with their application, with their service. So you're not seeing this API anymore. You're seeing this API. This API gateway is doing that orchestration between their own service. And you are in turn talking to their gateway, API gateway. That's the difference. So it's almost like your gateway that was sitting in your system that was talking to their API is now shifted into their system and is talking to their system directly, and you are talking to their API gateway. So the API gateways are doing pretty much the same thing that what I said the gateways are doing, barring probably the exception transformation. We're still talking HTTP, but it's simplifying the interface, it's simplifying the communication with that service, and that's essentially an API gateway. So far we've talked about the gateway design pattern and how the gateway design pattern is a superset of the proxy design pattern. The proxy is typically a code gen proxy, and it is mimicking. It's like bringing that service closer to you. So it's behaving as a proxy to that service, but it's replicating the API exactly. It's handling the communication and transport protocols, the proxy is, but its API, it looks exactly like that service on the other end. Instead of talking JSON, REST, SOAP, whatever it is, you're talking C#, but the method calls, the arguments in and out are exactly what that service is expecting. But that's a proxy. Now the proxy may use a service agent to handle the actual protocol parts to it or not. You may not see it as a different class. But there are many times where, let's say I've got a bunch of services in my system that are all using HTTP and let's say JSON, then I'll have a service agent that handles the HTTP, the JSON aspects of it for all my gateways, and then the gateways are then compositing the service agent within themselves, so they're not repeating the same logic over and over again across multiple gateways and are in the same code base. So it's possible that a proxy that's even code gen has a separate class generated as a service agent, or may not. Either ways, the proxy has the functionality either separate or built into the proxy itself of a service agent. And so a service agent is the innermost set. The proxy is a superset of the service agent. It does what the service agent does and then some. And the gateway is a superset of the proxy. So it's doing what the proxy does, what the service agent does. And then these three primary roles and responsibilities over and above the proxy and the service agent's responsibilities. So I think I've come to the end of the discussion part of this video. I hope this has been helpful. This is sort of the first time for me to be in front of a camera, at least doing the technical stuff like this. So I hope you enjoyed it. If you did, give me a thumbs up, give me a like. If you've reached so far and you're not a subscriber, please subscribe. And I'll see you in the next video. I'm going to say next video, but maybe it's not. Maybe it's the same video. Either ways, if this video's title is part 1, then there's a part 2. If the title of this video has no part 1 and part 2, then of course this is it. Until then, I'll see you next time. All right. So now we're going to look at the coding side of things of the gateway design pattern. What you're seeing on the screen here is a little Visio diagram I've shown you to explain the Visual Studio solution that I have made available on GitHub. You can find the link to that in the description. I'm going to start from the solution has multiple projects. So it has 3 projects. One is the sort of the service end of the whole equation, which is the stuff you see on the right hand side here, and the other is the client end of the system. In this case, the client happens to be a WinForms GUI application. So the service is just a simple service. It's nothing spectacular. I just needed a service that provided 2 completely different endpoints with 2 completely different protocols. So we have here, as you can see, there are SOAP endpoints in this application and the service application. The domain layer and things are just providing it with the data. The data is just in-memory data in this application itself, so it's not in turn going to a database and all that. So I'm keeping it very simple so that when you download this project, it should just work. You have no dependencies. This service application, as I said, fronts or surfaces 2 completely different endpoints for the functionality required. The functionality is the same, but the protocols are completely different. So one is the SOAP protocol, one is the REST HTTP protocol. The data is the same, and this is very, very simple. There's only one method, and as I said, one talks in REST, one talks in SOAP. So that's one aspect. There's sort of the happy path. Then there's the unhappy path, where is what if something goes wrong on the service. In the case of a SOAP, the SOAP endpoint, it throws or returns a SOAP fault, because that's what SOAP does. The SOAP protocol requires SOAP faults to be sent down the wire, whereas with REST, it's talking HTTP, so it returns these errors in the form of HTTP errors. So as we can see here. Now on the client side, there are two gateways. There's the base class, and then there's these two implementations. One is called Movies Gateway SOAP. The other one's called Movies Gateway REST. The UI allows you to change between the protocols effectively using either one of these two gateways. Again, just for demonstration purposes, I have a base class that is sort of the API, if you will, and these two have their implementations. The aim is for both these gateways to implement the pattern accounting for the various requirements that I stated earlier as to what is the gateway's roles and responsibilities. So the SOAP gateway has to respond or understand the SOAP faults and convert that to exceptions in the case of unhappy paths. The REST gateway has to understand the HTTP status codes and other content within the HTTP body and convert that to an exception. The exceptions are exactly the same. And it turns out that in this case, the service is also returning in the header the type of exception that was thrown, but that's just additional information. The clients don't have to use it. But in my case, if I'm building the service and the client side, I frequently do that so that the client side can throw a same named exception. So there's no sharing going on between these two projects. They don't share any code. There's no common assemblies. That's again intentional. But I can have a similarly named exception on the client side, so that when I look at the exception coming in from the server side, I can look at this HTTP header information, and based on that, I could throw an exception that has the same name, with, of course, all the information and data coming from the service side across the wire. And so then on the client side also, it looks like it's the same exception. So there's no confusion if you're working with end users or analysts. It's not there's a whole different exception and an exception message they're seeing on the client, and on the server side it's completely different. So it's just more like a convenience, but also kind of to keep your head straight about what's happening between the server and the client. But again, that's just a nice to know or nice to have feature. If you're not, of course, building the service yourself, you don't control those things. So I'm going to start on the coding side to show you the code from the server side, but the meat of this discussion is really hovering on the client side. So I said there are three projects. That's the service application. It's a web application that has the implementation for the SOAP and the REST endpoints. Very, very simple. If you look at it, there are two controllers. One controller for the REST piece. So you look at this. I seem to have zoomed in. Okay, sorry. Yeah. So this is a standard web API REST controller. It has one method called get, and it's using this code here to actually get the data. And this get could throw an exception. So I have the exception handling here that constructs this HTTP response exception. Essentially, it takes the standard C# exception and it wraps it up in a HTTP form to send it across the wire. Then on the client side, that REST gateway looks at that HTTP response and reconverts it, if you will, transforms it back into an exception on its end. And that's one of the big roles of the gateways. The SOAP side has a contract. So this is a typical SOAP contract with all this stuff required here if you need the ASP.NET compatibility, etc. And it's also got a method here called getMoviesByGenre, and it's using the same domain facade. So this code is exactly the same. Both endpoints are using the same sort of the backend piece, if you will. But again, it gets an exception, and in this case, it constructs a SOAP fault exception because that's what SOAP contracts do. So that's fairly simple. The domain layer, again very simple. Essentially, we just look at the managers. There's one manager here. As I said, the data is hard-coded. It's not going to a database, so that's all the data you're seeing. And then it's got a method here, get movies by genre, that detects a certain genre. So in this specific case, the idea is very simple. You can get movies by different genres from the front end, from the UI, and you'll see that in a bit. And for demonstration purposes, if you sent a genre of NA, if you picked the genre of NA as a filter criteria, then the business side throws an exception saying this is not a valid genre. Right? Just so I can demonstrate in a controlled manner unhappy path or an exception path versus other. So if you pick any other genre, you're good. But if you pick NA, then it's going to throw the exception, even though the front end actually, in the drop-down, you'll see the front end showing NA as an option. So one would wonder, why that is the case. But again, I've chosen the NA genre for demonstration purposes. Now I'm running this application so you can see the front end. Let me just continue with this. Oops, not sure what happened. Did I not run the service application first? Oh, it's become a single. That's funny. I don't know how that happened. Okay, so in case this happens to you when you get the source code, I thought the source code, at least I've never had this issue before on this machine. This is the first time I've downloaded the code, so I'm sort of going through that process of cloning the repo and starting off. So you might have this issue as well. Please look at this part. So I've actually, let me just show you again. So I've right clicked on the solution node here, over there, and I go into the properties, and then there's this startup projects. You need multiple, and there's a sequence or an order in which you want them to start. So I want the service to start first, because if the client starts first, then that doesn't help. So I want this to start first, but I need to move it up to the top. So it's going up. So now it's the first one. And once this starts, I can actually have this application start. Next, the client application. Right. So once the service is started, then I want the client application to start. So I'll just move that up in the second place. Okay, so that's the correct way to do it. Okay, so I'm going to run this application again. So the service is starting here. You see the website. The website's not relevant, but this UI is. So this is, as I said, there's a bunch of movies that currently it's picking it by action, and it's using the front end application. The client application is using the REST protocol. So of course, internally it's using the REST gateway, and I can filter by different genres. Right? I don't think they need animation. There's sci-fi, and so on. Thrillers. Right. So now I'll switch to the SOAP protocol here, and I'll do the same thing. So I'll start with action. Takes a bit to start up. Drama. You probably don't notice it here, but the SOAP endpoint is just slightly slower, and this is on my local machine. In the real world, the SOAP protocol ends up being quite a bit slow, just because there's a lot of noise in the SOAP protocol. There's a lot of data being transferred across the wire. All right, so now I'm going to pick the NA genre here. And of course, we know this is going to throw an exception from the service side, the client side gateway. In this case, the SOAP gateway will have to field that SOAP fault, convert that into an exception, and then throw the exception. So because we're seeing this happening now in the service side, it's throwing this construct SOAP, it's gone to this construct SOAP fault exception, which is cool. And it reaches the client side. The client side displays this exception message here. In case you can't read that exception message, it says invalid genre exception, and that's the message coming from the service end of the equation. Property genre message, please provide a valid genre. Possible values are action, animation, drama, musical, sci-fi, thriller. This information came from the service as a SOAP fault that got fielded by the SOAP gateway on the client side. Figure out there's a SOAP fault, and it takes all the information of the SOAP fault. It then constructs its own invalid genre exception on the client side. Even though the names are the same, they're not sharing anything here intentionally. And then the UI is just catching that exception and throwing it, showing it up like this, right? Okay, so that was the SOAP implementation of that. Now I'm going to pick the REST version of it. I'll just go to another genre, and now pick NA again. So now on the service side, you're seeing this. It's saying construct HTTP response exception. Again, it's got a regular C# exception. It converts that to a HTTP based exception with a status code and content, the body containing a bunch of information. And now I throw that, and finally it comes to the client side, and the client side then shows exactly the same information: invalid genre exception, property genre, message, please provide a valid genre, etc., etc. So they both look the same, and this is the point. The point is that the business system, which is in this case the entire client application except for the gateway, expects the gateways to work for it, and it doesn't want to know about SOAP or REST. That's the job of the gateways. So the gateways are encapsulating all of the nuances of the protocol, the exceptions, and what have you. Their functions are the same. They could potentially be going to two totally different services. And of course, their exception messages will be different, but that's just a display mechanism here, or a logging mechanism, as you might do in the real world. But an exception is thrown. The UI or the business system knows how to handle those exceptions, but it doesn't understand that this exception came from a SOAP fault, or this other one came from HTTP REST, or whatever the case may be. Now, in this specific example, one of the other features or roles and responsibilities of a gateway is mapping. In this specific example, I don't have any example of mapping from one shape of data to another shape of data. The shape is the same, but I believe mapping, people understand mapping, so I haven't really spent time in trying to produce two completely different shapes of data, and so I can show the mapping. Right, so let's go and see the gateway now. Let me also just shut down the UI. Okay, now the gateway, the gateway is on the client application, and I'll file this folder for the gateways. And in the gateways, you'll see there are essentially, there's a base class, then there's the REST implementation, and then there's the SOAP implementation. This naming convention is something I use all the time with when I'm using kind of families of classes. Instead of saying, base movie gateway and REST movie gateway and SOAP, I actually do the other way around, so they get arranged correctly and in the same alpha order, if you will, in the Solution Explorer. And it becomes very easy to look at or know that there are n number of descendants to a basic, like a family, if you will, of classes. And so movies gateway REST, movies gateway SOAP. And if I go into the movies gateway REST, keep in mind this idea here is not to Of course, you can see the gateway being built and how we implement the code, which is good production quality code, if you will, but it's a very simple application. And it essentially goes and gets the movies by genre. And this is as part of the API. If you remember, I said, the gateway works for you, it works for the business. Whatever that method might be called on the service end, this is a method that the business system is going to use. The business system is saying, hey, gateway, get me movies by genre. Because this is a protected method. The business side just sees the public method, which is just called get movies by genre. It's a business or a domain-centric name. The names of these methods in the gateway should be the names as the business understands what it is asking the gateway to do for it, not the other way around. These are not the names of the service endpoints. So the service endpoints have got a completely different thing here. In this case, it's API/movies/some genre, right? And then this method eventually is going to have to, in the gateway, this method would get the mapping done. It would handle the exceptions and do all of the rest, right? So once it's got the data from that endpoint, you see here it's doing the transform exceptions thing here. So we have got an exception transformer. You can take a look at that code. Essentially, it's taking the HTTP response message. It determines if there's an error from the server side. If there's an error, it throws an exception. If there's no error, it just comes down to the next line. And the next line here now, before you could sort of map it to your domain models. As I said, I'm not taking the trouble of having two completely different models, as in two completely different shapes of data, that one that came from the service and one that the business side needs. It's the same. But once you got this movies, let's say if the shapes were different, once you had the movies collection here, you would have to map it and then return whatever the, let's say, movies domain versus movies service, let's say two different shapes. Then you would have to map it from movies service to movies domain and return that here, right? So this implementation is going across to the service, getting the data, getting a response back basically. Once it gets a response back, it looks to see if there's an error. If there's an error, then the exception transformer will throw an appropriate exception. But if there is no exception, it just comes down to the next line, and it then, in this case, is deserializes it from using JSON, whereas in the SOAP implementation, it'll have to do its own deserialization, if you will, right? The implementation is not so important as much as the sort of the steps, the roles and responsibilities. What does a gateway need to do? Now, if you look at the SOAP gateway, now the SOAP gateway in .NET, we have a facility, the channel factory, where you give it this movies contract and protocol, and the channel factory then will build you a proxy. So this is the gateway. This gateway is using a proxy internally. As I said, a gateway is like the superset, right? The gateway may or may not use a proxy. The proxy may or may not use a service agent. In this case, because we get this out of the box in .NET, the channel factory will create you a channel, which is really a proxy. Even though they call it a channel, in my mind, it's a proxy. So I've called it movies contract proxy, right? And then the get movies by genre method implementation will get movies by genre from the proxy. Remember, the proxy is mimicking the sort of the contract, in this case, the API of the server side. Now they happen to have the same names, but this name has been determined by the base class, and the base class's API is determined by what the business system wants, not the server side. They happen to be the same name. Maybe it's a bad idea to have the same names here, but it is what it is at this point. It gets the movies. If there's an exception, it catches the exception and it creates a domain-specific exception from that SOAP information. Right? So this thing over here understands how to convert a SOAP fault into a domain exception. So this is the exception it needs to throw, but what it's getting back is a fault. And it knows how to convert that SOAP fault into an exception with the message and everything else. So look at the implementation of the movies gateway SOAP. in the movies client application here, you can, so in the movies client application, you have a gateways folder that has the base class. It has the two implementations for the different gateways. It's also got the exception transformer here. Now you could potentially have two different transformers, exception transformer rest and exception transformer SOAP, rather than implementing it in the gateway. As far as how you decompose the gateway, whether you use a proxy and or a service agent or don't, or implement the whole thing within the gateway itself, whether you use the exception transformer as a separate class or not, that's all implementation dependent. The roles and responsibilities don't change. You can have all of the code in the gateway, or you can have different specialized classes that help the gateway do the different parts and pieces, the mapping and the transformation and the protocol parts, right? So this is not about the implementation as much as it's about demonstrating how, if a business system is working with a certain API for a service, where the API is designed as per what the business wants, not what the service is giving you. The language of the domain, the API methods are in the language of the domain. What is the domain seeing that service? And as an example, maybe you go to IMDb and IMDb says, I can give you a bunch of movies. But from a business standpoint, maybe it's not movies. Maybe it's they call it assets. Maybe they call it entertainment, or whatever the case may be, right? So you're going to say, get entertainment by genre. It's not get movies. IMDb knows it as movies, but this business, let's say, knows it as entertainment or videos, whatever, right? The gateway's API needs to be in the form of the business. So this is the base class. It has this get movies by genre, which is what the business system is seeing. And then internally is calling get movies by genre core, which is what the implementations of the two different descendants is actually implementing. Right? So it's got a bunch of other methods here, get movies by year. So that's how the business understands this. It says, I want you to get me movies by year. Whether that service calls it movies, whether it calls it by year is irrelevant. This gateway is working for the business. And this movie DTO is a domain model. Now in this case, as I said, the server side is using the same domain model, the same shape and everything else, but that's not the point. They don't share. Again, there's no sharing going on. There's a movie on the client side, there's a movie on the server side, two completely different classes share nothing. But they're both called movies and the shapes are both the same. Right? So that's unfortunate. I should have probably made a better example. But this movie shape, the DTO, the shape of the DTO is based on what the business wants. And as you saw in the implementation, the gateways are each going to their respective endpoints. There could have been two completely different services provided by two completely different vendors. As long as the business need is the same and both these endpoints, both these services satisfy the business requirements, it really doesn't matter. Right? The API of this class, the base class, which is being used by the client application, has no reason to change because the business on this end has not changed. Those two services by completely different vendors provide you with the functionality the business requires. Then you just need one base class with the same API, and the client application is really talking to this API. It doesn't know about the two different services per se. It just knows there's two different gateways. They have the same API, so it really doesn't matter which one you use, right? So, well, I hope this has been a good example for a gateway that makes sense. I know the project is fairly simple, but yet there's a lot of code here. And this code is available on GitHub. You can clone it, or you can just download it as a zip file on your machine and open it up and take a look at it and use that as an example. So thank you, and I hope you enjoyed this and found it very useful. And I'll see you next time.